Thermal expansion occurs when there is a change in temperature. Usually when the temperature decreases, the material will contract and shrink, and when the temperature increases, the material will expand. The material properties will define how much of the object will expand or contract. The equation to calculate the thermal expansion is alpha, which is the material property, times the change in temperature times the length. Make sure that you always find the change in temperature, or in other words, the final temperature subtracted from the initial temperature. The coefficient of temperature can be usually found in a table. It is specific to whatever material is being used. Now we will do an example problem with thermal expansion. Here we have a beam that is suspended between two walls, and then the temperature rises. Now the question is, what will the wall reactions be? To solve this, we are going to need principles of superposition. First, let us replace the walls with force reactions. That means we can sum the forces in the x direction. That means that force 1 and force 2 are going to have to be equal to each other. Now to apply the principles of superposition, we need to remove one of the forces. Then we imagine the member growing due to the increase in temperature. Then we realize that the member can't grow due to being stuck between two walls, and therefore it must be pushed back by the wall reaction. We understand this as that whatever change in length were to happen by the change in temperature, the wall must push back. Therefore, delta grow is equal to delta shrink. We can easily calculate the delta grow because it's just the formula for thermal expansion, and that is equal to this amount. But delta shrink has a bit more involved in it because we will use PL over AE to help us find the displacement. This equation will have one unknown in it, being the force and the wall reaction required to keep the rod at a constant length. When we set these two equal to each other, we can solve for the force in our wall reaction, and the result is 504 kilonewtons.